Okay, you'll have to bear with me on this video. I don't have much space to do this lesson, so I'll do the best I can. Page 23 in your notebook. So I'm going to write page 23 up here. Page 23 in your notebook is going to be Student Journal, page 69. Student Journal, page 70. And Student Journal, page 72, I think. Yes, Student Journal, page 72. All of those are page 23 in your notebook, and the title is what the title is up here, Function Notation. So I'm doing this so you won't miss out on any instruction this week as far as math class goes. So the first activity that I have students do, is to work with their partner and try to match these functions, and I've got just a few more, as you can see on the paper, those functions A through D with the graphs at the bottom of the page, A through D. Now hopefully you can look at these and you can think in your mind, okay, this is not linear, this is linear, this is linear, this is not linear, this is not linear. And we can go back up to the top and we could look at those four equations that are given, and we could be able to pick out which ones are linear. I'm going to highlight which ones are linear. When I look at them, and you don't have to highlight, I'm just going to highlight so we can see. A is linear and B is linear. So I know when I go to match, I can only match that A and B with either B or D. And then how do I decide after that? Well, I believe that you learned in 8th grade about positive and negative slope. This line rises to the right, so it has positive slope. This line falls to the right or rises to the left, so it has negative slope. So I'm going to use that when I'm deciding which of those two problems above are either B or D. So when I go back up here to the two that I highlighted pink, one thing I want to point out, I want you to know, is that y is the same thing as f of x, and y is the same thing as g of x. It's just a different way to write equations using function notation. Y is the same thing as h of x, and y is the same thing as j of x. So all of those are also equal to y. Now, looking at those first two, which of these has a positive slope? Does lowercase a have a positive slope, or does lowercase b have a positive slope? Well, hopefully you can tell that lowercase a has a positive slope, and then down here at the bottom, we said capital B has a positive slope, so therefore B is what goes with lowercase a. Then that means D has to go with lowercase b. Now, when I look at not only the slope here, the slope and the slope, what about these numbers? What do these numbers mean? Hopefully you remember it's where it crosses the y-axis. So if I look down here, negative 3, 2x minus 3, so it crosses at negative 3, and then positive 2. And then when I look at the equations, positive 2, negative 3. So I can use those numbers also sometimes with equations, which is what we did with C and D. I know, just by process of elimination, that both of the graphs at the bottom, capital A and capital C, have to either match C or D. The slope really doesn't help me much, but this number here and this number here will help me decide which of these to use. Negative 1 is the number here. Which of these two equations crosses the graphs crosses the y-axis at negative 1? That would be A. So A goes here. So by process of elimination, I know that B is going to go here. Sorry, C is going to go here, capital C. But let's look down here. Here's a -3. Crosses at -3. So I'm going to pause and go on to the next page. Okay, here's the next page. I wanted students to see this function notation. And hopefully you can tell, remember I said on the previous page that f of x means y. And look, f of x means y. So anytime you see that f with a variable or a number, that just means y. So all the way down through here, this is the y coordinate that goes with -1. This is the y coordinate that goes with 0. This is the y coordinate that goes with 1. And then this bottom one, this is the y coordinate that goes with 2. So all of those are y. Now I want to write something over here on the side, and I would like you to write it down also. When you encounter f of x, that just means, of course, that means this is y. And when you have -1, f of -1, all this says mathematically is the value of y when x equals -1. So knowing that, I can go up here to this graph, and I can go to -1 on x, and then I want to go up here. I'm going to go up the graph. What is that value there? When x is -1, what's y? And hopefully you see it's 4. So the answer is -1, 4 for letter A. F of -1 is 4 because when x is -1, y is 4. Let's do the same thing for the second one. I want to find what is y when x is 0. So I'm going to go to 0 for my x, and I'm going to go up 1, 2, 3. So y is 3 when x is 0. So 0, 3 is the answer I put over here. The next one, I want to find y when x is 1. So go to my graph, go to 1, and then go up and find the y value that you see for... Okay, so as I continue, sorry about that, I was on this one. It's on letter C. Give my camera time to focus. There it goes, maybe. How about here? There we go. So, find y when x is 1. So, I go over here to my graph, go to 1, y is, looks like what, 2? Yes, so 1, 2. That's my ordered pair answer for letter C. And then the same thing here, find y when x is 2. So find the graph. When x is 2, y is 1. So 2, 1 is that answer. Now as I look at this, there is another way that I could have done these. You know f of x equals -x plus 3. If you want to, if you didn't have a graph, then you could substitute -1 in for x. Hopefully you can see that -1 has been put in place of x. So then to find that value, in place of x, where x is, I'm going to put -1. Then I'll do order of operations. -1 is +1. So if you notice, we did get the answer right. 1 plus 3 is 4. When x is -1, y is 4. When x is negative 1, y is 4. So you can also substitute and find the missing answers. One thing I say about function notation is that this is just a fancy way to show you to substitute. Now, I want to look at the bottom, down here where it says communicate your answer. It says, how can you use function notation to represent a function? Well, they've shown you. This is how you can do it. The purpose or the reason is, I was telling first period this morning, and you do not have to write this down, but what if I gave you several equations? Y equals 2x plus 1. Y equals 3x minus 5. Y equals 2x, and y equals 4. Okay, so let's say I gave you those 4 equations, and I asked you to use the one that starts with y for a particular problem. Well, hopefully, when I would ask you to use the one that starts with y, you would ask me which one. They all start with y. So function notation then helps us to distinguish between each different function, and I could call them each something different. And remember, all of these things mean y, so I'm not really changing anything. So now if I ask you to use a function that started with g of x, then you would know to use this one because it starts with g of x. So it's just a fancy way to write y so that we could represent different problems and make them look different besides the expression that's on the right. So that's how you can use it to represent. It says, how are standard notation and function notation similar? Well, they're similar because, look, this expression and this expression are the same. So that's how they're similar. How are they different? Y is replaced with f of x. So that's how they're different. Hopefully that all made sense. That is what we had discussed in first period. I will attach today's warm-up to this post as well so that you can have at least Wednesday, Thursday, and Friday's warm-up in your notebook. Thank you and have a wonderful weekend.